Good afternoon. So I promised 1 or 2 more numbers today, then we can have the last explanation. So we have a beam of X-rays. Beam of X-rays of wavelength. 1.0 times 10 to the power negative 10 meters is incident on a set of cubic planes in a sodium chloride crystal. First order diffracted beam is got for a glancing angle of 10.2 degrees. Sometimes they set numbers with the glancing angle of around, they can tell you 10 and 15 minutes. It means the decimal place in minutes has to be got from 15 divided by 60. I wish I can handle a number of that kind so that I show you how we handle it. Find the density of sodium chloride. Avogadro's number Na is equal to 6.02 times 10 power 23 atoms. This is our number. Now with this number, we're going to look at, it's a crystal which is having sodium chloride. And remember we have the formula we talked about last time, which is given by mass times 10 power negative 3. When you convert the mass to kgs, divided by Avogadro's number. This is now the mass of one atom, one molecule. So divided by 2d cubed. Now why is the d having a 2? The d is having a 2 because sodium chloride has got 2 crystals, 2 atoms. One atom is for sodium, the other atom is for chlorine. By 2. So instead of going the other way of presenting with the way how you go ahead and divide, you can use this formula straight away and you get the answer. But we do not have d yet, and d can be got from lambda n is equal to 2d sine of theta. So lambda n, we can get d from n lambda over 2 sine of theta, which will give us first order is 1 times 1.0 times 10 power negative 10 divided by 2 times sine of 10.2 degrees. What answer do we attain? Press the calc and give us the answer.
8.85.
Sure.
8.85. 8.85.
Sure. 8.85 times 10 power.
-12.
Guys, come again. Someone else press the calc. She has this. Someone else try to press the calc and confirm the answer. Otherwise, we have something a little bit different.
Shami, I'm getting something different.
Yeah, give me what you have. Because even me, I'm doubting this one.
I'm getting 5.117 times 10 power -11.
We have a gentleman. One guy, give us your answer and we take a look.
Yeah, I've got 2.8.
Correct, that's the correct answer.
2.84 times 10 power -10.
Let's look at your calculator. 2.824 times 10 power negative
times 10 power -10.
Correct. 10. This is the correct one. These ones, guys, put your calculators again. If you don't know how to press the calc now, you'll have a problem presenting in a paper. So we have got D. So therefore, density can now be got from the mass was given as what? Were we given the mass? I think I missed the mass. Sodium chloride crystal of molecular mass. The molecular mass was 58.5 grams. Sorry, I missed the mass. So this would give me 58.5 times 10 power -3 divided by 6.02 times 10 power 23 times 2 times 0.824 times 10 power -10. But the whole of this one has to be cubed. Now, can you carefully press your calculator? What did we get? Yes, please.
2,157.423.
These are kilograms per meter as what? Cubed. My ladies, we are getting the other answers. This time around, are we getting the same? Ladies, Can I hear someone else with a same or similar or different answer? I guess you're all getting the same, huh? Okay. If you're all getting the same, let's look at this last example. This last example is having what we call it's a reverse order. You have to look for the atomic spacing backwards. They have given you the density, they have given you the mass. Now, they have told us mass is equal to 74.55 grams. The density is 1.98 grams per cc. If I want to convert the density to kilograms per meter cubed, I multiply by 1,000. So 1,000 times 1.98 will give us 1980 kilograms per meters cubed. Then the mass, if I want to convert the mass to kgs, I'll have 74.55 times 10 power negative 3 kgs. Our expression says density is obtained from mass over Avogadro's number divided by 2d cubed. Therefore, now this was for potassium chloride. Potassium chloride also has 2 atoms. Otherwise, if it was having 1, this would have been 1. So that's the reason we have these 2 there. So d cubed can be made the subject to have m over 2 Na of rho. Therefore, d cubed would give us our mass is 55 times 10 power negative 3 divided by twice the number 6.02 times 10 power 23 times the density, which is 1980. Can you press the and then get the value of d, the square root of the answer you've got.
Excuse me, teacher.
Yes, please.
Teacher was asking, since the mass of the potassium chloride is determined by the density, couldn't we just work it out without first changing them to kilograms?
Just work them out without first changing them to kilograms. If you do that, these atoms, number of atoms, they might not be in position to affect much the dimensions, but because they are standard, work them out using those standard units. Also, another thing is you'll come to get a tube root, which tube root would differ in the result you get. The result you get might now, in that case, be it might not be in meters, it might be in centimeters. If it is in centimeters, then it would be a very big value, which might not, if you're comfortable with the way wavelength or spacing looks like, if you get that answer, it might scare you that it might differ so much from the usual answers you get in meters. So it's better we work in SI units.
Okay, thank you, teacher.
Anytime. So what answer do we get?
Answer, guys. People are failing to compute.
3.15 times 10 power negative 10.
Final D is 5, 1 times 10 power negative 10 meters. So sometimes they'll ask you to work backwards. Eh? Okay, have that down. Then the last discussion I want us to talk about is what we call the X-ray spectra. Sometimes we call it spectrum. I'll send a picture of this for the better explanations to make a better write-up. So here I'm going to just discuss as I highlight some of the key points in the explanations. Basically, this consists of two types of spectrum. So there are two types of spectrum. When it is one, it's called spectrum. When there are many, they are called spectra. So we have spectrum, which is called line absorption spectrum. Then we have also what we call the continuous spectrum. Okay. We also have what we call the continuous spectrum. Now, when you look at these two spectra, they're different, quite different. One is called a line, this one is called a continuous spectrum. Whereby these two different spectra depend on, for example, the line absorption spectrum. Sometimes you call it the line absorption spectrum. It depends on electrons making penetrations into the target atoms so deep into the nucleus. For example, if this is the nucleus of the atom, which is positively charged, we have some electrons around the nucleus. Some of you have electron configuration senior to, I think, for chemistry. So an electron, an X-ray photon, comes and penetrates so deep inside into the nucleus of the atom. Then it comes and disperses the electron in the innermost shell, leaving there a vacancy. Now, when that vacancy is left, what happens is, when the vacancy is created, it shall leave a gap, and the atom will become unstable and excited. When the atom becomes unstable, we are saying, for the line spectrum, line spectrum occurs as a result of occurs because of what we call electronic transition, which I wanted to end with when I'm giving my explanation. But electron transition occurs as a result of a photon. A photon is what is comprised, it's what makes
the X-ray beam. Those many photons, they make the X-ray beam. So one photon can go inside the atom and penetrate so deep inside of the atom, then knocks out an electron in the innermost shell. So it has so deep up to here, and it has knocked out an electron. So this electron has been taken out of the atom. So a gap is going to be left. For example, if it was like this as the first orbit, the electron which was here, now there is an empty space. There is an empty space, the atom is not electronically balanced. So it's going to become unstable and excited. When it becomes unstable and excited, an electron transition will occur. By these electrons which are up here, they'll make a transition and move to come and fill the vacancy that has been created. In that way, when they're making a transition from one orbit or from one energy level to another, because sometimes these orbits, we call them so it makes a transition from one energy level to another, it emits energy. That is why we are saying the line spectrum is as a result of electron transition. When electrons are transiting from one energy level to another, they emit energy. The energy they emit is going to form lines, spectral lines, and those spectral lines are what correspond to the line spectrum. So that is how the line spectrum is produced. So what is required here is one, energetic. When energetic X-ray photons penetrate deep into the nucleus, into the atom or close to the nucleus, into the atom. What do? They knock out electrons in the innermost shell. What happens when the electrons are knocked out? And these electrons can either be ejected, electrons are which have been knocked out. Electrons either ejected or they ejected out of the atom, or they can go and occupy higher energy levels, or they can occupy higher energy levels. That is depending on the energy of the photon, the X-ray photon that came in. Remember, I've said these X-ray photons, if this is an X-ray beam, this X-ray beam has photons P. And these photons P are what make the beam. But this single photon is what has gone and penetrated so deep inside into the nucleus of an atom, to the innermost shell, and then it has knocked out an electron. So this puts the atom in an excited state, so it becomes unstable. This puts the atom in an excited state, and it becomes unstable. The atom is unstable and excited as a result of having the gap deep into the innermost shell. So the subsequent electron transition from higher energy levels causes high energy X-ray photons. Something I've mixed up. I said energetic X-ray photons. No. These are not X-rays which penetrate. They are energetic electrons. Energetic electrons
are the electrons? Remember our X-ray tube, we move electrons from the cathode and they go strike the target atoms of the anode. So those atoms we strike, they are being struck by electrons coming from the cathode. It's the electrons which strike the atoms and penetrate inside the atom. Now when they do that, they are going to eject the electrons which are inside the atom. When they ejecting them, a transition will occur by electrons in high energy levels to come and fill the vacancy left. But as they do those transitions, what is happening is, when they carry out such a transition, we are going to cause high energy X-ray photons to be emitted of definite wavelength. So, becomes unstable. Then you can say electron transition occurs from higher energy levels causes high energy X-ray photons to be emitted of definite wavelength. Should I write this part? To be emitted of definite wavelength ranging they can range from a given value to a maximum. Someone's going off and coming back. X-ray photon of definite wavelength to be emitted. But you shouldn't worry, like I said, I'm going to send here notes for you to have. So the energy of the X-ray produced, the energy of the X-rays produced is equal to the difference between the energy levels. We shall discuss energy levels later. So this is what causes this leads to formation of an X-ray line spectrum. So this means E2 minus E1 is equal to HF. So if E2 is the energy level up here, where the electron made a transition from to come to E1 to fill the vacancy left, then the transition it has made has been accompanied by the change in energy. So the change in energy is equal to HF. Sorry for that inconvenience. Does not mean that your time is up. Some of you might think your time is up. So that's how the line spectrum behaves. But we shall discuss more about this. This one we cannot get it away right now. But when we come to discussing more of energy levels and orbits in the hydrogen atom, we shall see more of that. We also talk about the continuous spectrum. If you hear the word continuous, unless someone has a question on what I've explained so far.
Excuse me.
Yes, please.
Teacher, about where you said the electrons are either ejected or they occupy higher energy levels. I'm so confused.
Okay.
Now this is what takes place. Let me sketch for you a diagram here. What happens is, this is the nucleus. This is the
First, second orbit, third orbit.
Now, if we had electrons here in the lowest energy level, then we had other electrons here. Then we had other electrons within. What if we had another energy level up this way? Now, when an electron comes and it penetrates deep into the nucleus,
And it comes and knocks out this electron.
this electron can rise up to here, sit there. It can be totally thrown out of the atom. It goes to infinity. When they say it goes to infinity,
It means it has gone out completely. Now, when that happens, it means the energy of the electron which knocked it was very high. While if it does not totally go out, it means the energy was not so high. It was just enough to displace it from the lowest energy level to a higher energy level. But if it completely knocks it out to go out of the atom, it means the electron which knocked it had very high energy, which was capacitating it to go up to infinity. And if it goes up to infinity, it means it has gone out of the atom. So it will leave a vacancy left. If it remains within, the atom easily stabilizes because the transition occurs from another energy electron to come and fill the vacancy left. So as that one also goes on meandering where it has landed, cyanide and the atom will end up stabilizing after this one has landed down. Because you know, for stability of an atom, from chemistry, should occur in even what? In even pairs, not odd, don't you? For example, 2 to 8 to, yeah? I don't remember my chemistry very well. 2 to 8 to what? To 2, yeah? Whereby this one is even, stable. Okay. I don't know whether I've answered your question. To answer your question.
Yes, teacher. Thank you.
Okay. Now, for continuous spectrum, it occurs as a result of multiple collisions of the electrons with the target atoms. What does that mean? That as these electrons are coming from the cathode and they are striking the anode is made up of atoms of that metal which is high. So as more of these electrons strike the target atoms, they are colliding with the target atoms. Yeah? When they collide with the target atoms, what happens is they are going to be decelerated. Their speeds are going to be reduced. When their speeds are reduced and they are decelerated, then they are going to give off energy, or their energy is going to first be lost. Now, when energy is lost, some of their energy is what is being converted into X-rays. So some of the energy will be given off as X-rays, and the X-rays will be having varying wavelength from a certain value to a maximum. And that varying wavelength, the value from which it starts, that value is called the cutoff wavelength, as we shall see. And this cutoff wavelength is produced or is attained if and only if when the electron which is colliding with the target atom decides to lose all the energy it has to the atom in one single encounter. There, with that regard, the X-ray photon produced will have what we call the minimum wavelength, or will have what we call the cutoff wavelength. I will not write a lot because I'm seeing if I write a lot, time will not be enough. So I was saying, this one has what we have, what we call multiple collisions of electrons with target atoms. The electrons are decelerated When they are decelerated, they lose what? Kinetic energy, or they lose energy. When they lose energy, X-rays are given off. Varying wavelengths. From a minimum to infinity. But the minimum wavelength produced is what we are calling the cutoff wavelength. So we need to know how this cutoff wavelength is also produced. Minimum wavelength. Sometimes we call it the cutoff wavelength. We have said it is produced when electrons striking the target atoms lose all their energy to the target atom in one single encounter. And this results in production of the most energetic X-ray photon. This leads to production of the most energetic X-ray photon. Frequency. And you know why this happens? This is the reason. Because energy is given by the formula HF, but F is equal to C over lambda. So now you have C is speed of light. If I have minimum lambda, I'm going to produce maximum energy. X-ray photon produced will be of maximum energy. And this is equal to EV. So if you want to take a look at the graphs and see how they look like, this is how the graphs are going to look like. Let me take an illustration on the graph. The graph of the shape of this kind, having this as lambda, having this as intensity of the X-rays. So, as the graph rises, it gets protrusions, which correspond to lines. So this part is what we call the continuous spectra. Continuous spectrum. Then this one is what we call the line spectrum. So this lambda here is what we call the cutoff wavelength, which is wavelength what? Minimum. At times they can ask you to plot intensity against frequency. You know, frequency and lambda are inversely proportional. Intensity against frequency. This is intensity against frequency. To take a shape of this kind. This will correspond to our line spectrum. This will correspond to our continuous spectrum. And this is now frequency. For this one, this was our lambda wavelength. More to that, I can also talk about this last graph. So that I finalize X-rays. Please read about X-rays. Go on the internet, search about them, download them, take a close look at them, read more and get more information about them. This is one of the best things you have in this session. You have opportunities of visiting the internet without limit. You normally say at school they limit you in the computer lab. Here you have your phone. The dial for the search of X-rays is just a dial away. So just dial on your phone and you can be in position to read more about X-rays. So we have, if these are the energy levels of the bits, this can be called the shell, the M shell. This can be called the L shell. And this one can be called the K shell. So the transition is made from the N shell to the M shell. Then we shall have what we call the M series. This will be, for example, M alpha, the X-ray photon emitter. The transition is made from N to come to L from any higher energy levels. Then, for example, this will be L alpha, L beta, and this will be the L series. Then if a transition is made from N to come and land in the K energy level, then this will be K alpha, K beta, and this can be K gamma. Now these series are called the K series. These ones are called the L series, these ones are called the M series. So if you go and illustrate this on the graph I've been looking at, a graph of wavelength against intensity. And this would look like this. We start with the K series. Then we go to the L series. So this one will correspond to K gamma. Then this one will correspond to K beta. Then this one will correspond to K alpha. These are spectral lines. When a transition is made from N to K, by K, the line produced is K alpha. So the line K alpha is this one. The transition is made from M to K, then the line produced is K beta. When a transition is made from L to K, the line formed is K gamma. Sorry, it's from order of the left to right, and then the reverse is true. Now look at this one. Let me illustrate using the second one. When a transition is made from the N series, from the N energy level to the L, then the line produced is the L beta line. So L beta line is this one here, the first line. Then when a transition is made from M to L, yeah, from L to L will give us the L alpha line. Lastly, if you look at the transition from N to M, N to M, we have a M alpha line produced. M alpha line is this one.
So these are some of the graphs that can furthermore say something about the X-ray spectrum and about the energy levels in an X-ray spectrum. We have 4 minutes. Can I have some questions? Okay. No questions. Allow me send the notes so that people can update their write-ups.
Teacher,
Yes, please.
teacher, when you were starting to explain the continuous, I mean the what? The line spectrum, my network went off. So
Okay,
the question
contact
maybe
me
if you have something.
for the video.
I want, yes, a video
Okay, I'll send
at
it.
night.
Let me convert it right now and send it right now.
Okay,
Thank you.
then we can call it a day, guys.